Welcome to the Alibaba Cloud webinar series. My name is Nuruddin Abbasali and I will be your host for the day. In today's webinar, we are going to talk about why organizations are moving from a single cloud to a multiple cloud, or as we like to call it, a multi-cloud strategy. Towards the beginning of this session, we will cover some of the many reasons why organizations, both customers and vendors alike, are already considering or need to consider the multi-cloud strategy. What are some of the key drivers and challenges and business problems that we are trying to resolve? Thereafter, we look at what it means for an organization to step into the multi-cloud world. What are some of the many ways an organization can deploy their applications across multi-cloud? We go on to discuss some of the common use cases and their corresponding challenges. Towards the later part of the session, we discuss how at Alibaba Cloud we truly believe that enterprises should adopt this model and discuss how we are designing our services to ensure that our customers can create an effective multi-cloud strategy. The last part of this session is reserved for questions that you might have. Please note that you can submit your questions using the button at the bottom right at any time during the webinar. We will try our best to address as many of these as possible towards the end. So why should we multi-cloud, you might ask? In order to answer that question, we need to look at a few fundamental concepts and a few new ones. Fundamentals that are the promise of the cloud cure and the new but not so new challenges that are faced by organizations when they are adopting a single cloud strategy. This should not come as a surprise. If you go to the early days of cloud, one of the biggest promise and reasons for organizations to adopt cloud was because they were tired of the vendor lock-in created by the hardware and software vendors in the enterprise space. But somewhere along the way, did the cloud drift towards a similar yet different problem? When organizations moved towards cloud, they soon realized that all the work that had gone into addressing these regulatory requirements had to be now redone. It had to be redone for the cloud, and the complexity of it all was quite different when compared to a non cloud environment. The reasons for this were very simple. The non cloud on premise environment provided full control to the consumers themselves. However, with that lack of full control on the environment, ensuring regulatory compliance became a challenge. The third driver is more of common sense than something related to multi-cloud. Even though most cloud providers give highly competitive service and data availability SLAs, does it for any business make sense to put all of their eggs in one basket? Soon after the honeymoon period for cloud was over, most enterprises, except for companies born in the cloud, realized that they could move some but not all of their systems to the cloud. Some of the reasons were legacy applications, regulations, cost of transformation, or a number of other reasons. So, does that mean that these organizations cannot benefit from the cloud transformation, or does the multi cloud have a solution for them? There are a handful of large global providers, and then there is a list of smaller ones. No matter large or small, each of these cloud providers have their specialty areas. These may be in terms of technology, innovation, or even geographical distribution. With the dynamic nature of business these days, customer requirements are constantly changing, and no single cloud provider can keep up with all these requirements. When looking at organizations seeking vendor independence, The issues plaguing them can be broadly categorized under two categories, namely technology and cost. Looking at technology, single vendor dependency exposes an organization to a multitude of risks. Let's say you had a business, company A, that built a service based on a specific cloud vendor technology. Now, while this would provide you with a uniform and specialized product, the organization would be completely dependent on this single vendor for furthering the underlying technology and support. And then, what if for some reason that technology was discontinued by the specific provider? Another issue could be the exact opposite, where the technology update cycle is too fast for an organization to keep up with. The question that this company A needs to ask itself is how portable is their service in terms of both infrastructure and technology. The second and more apt concern for company A would be cost. For the same business A, what does it mean if the cost of the underlying infrastructure and technology suddenly changes? What if the service price are hiked? Let's say they have deployed a number of servers and the server costs are doubled. Or what if the pricing model of certain underlying services suddenly changes? For example, let's say services that were measured by bandwidth are suddenly now measured based on connection requests. So, what are the business challenges? From a technology perspective, it would mean complete dependence on a single provider for backend innovation, service continuity, and reliability. This would eventually lead to a vendor lock in. If you remember, this is precisely what we were trying to avoid moving from typical enterprise workloads to cloud workloads. In terms of cost, company A would be faced with a challenge in terms of cost planning and optimization, as there is a direct dependency of this cost on the prices of a single cloud vendor. When we talk about regulations again, there are two factors that come to mind: government and industry regulations. These might seem obvious, however, they are often missed due to oversight, which means businesses must plan for them rigorously and well in advance. It is common these days for different government bodies to put restrictions, limitations on certain kinds of services. It is also not uncommon that a country might impose a ban on working with providers from a particular region. This may be due to any number of geopolitical reasons. What does a company dependent on a particular cloud provider from such a region do to comply with government regulations? Another form of regulatory compliance is driven from vertical industry bodies. These might be, for example, banking regulations that don't allow customer data to leave the country, or DR requirement that needs another physical location which might not necessarily be available within your existing provider. Or it could be a high availability requirement under a stringent SLA requiring a separate provider. Does it mean that an organization needs to move their entire cloud infrastructure from one provider to the next when faced with any of these challenges? If an organization is running a global service, does it make sense to have a heavy dependency on local government policies? And how do these organizations meet the multitude of compliance requirements that might change with new upcoming services? So now we come to the old saying for not putting all your eggs in one basket. And believe it or not, it is as relevant to the cloud business as it was to businesses before it. What do you do if your beloved cloud provider suffers an outage? An outage due to a technical failure or some other reason. Yes, all the safety measures and SLAs and compensations kick in. However, as a business, you need to evaluate if that is enough to give you comfort. And if not, then how have you prepared for it? And what if your cloud provider goes out of business? It is a possibility, and we have seen this happen in the past, which means it is imperative to have a strategy for the same. As much as we would not want it to be, even today, the ground reality for a large number of enterprises is that not everything can be pushed to the public cloud. There can be a multitude of reasons for this, varying from technical limitations of legacy applications, low latency requirements, to corporate or industry data regulation requirements. These inhibit the move to public cloud. Does that mean that organizations should not adopt the cloud or have silos where some applications run on the cloud infrastructure while others were run on non cloud environments? Irrespective of what the next sales pitch tells you, we all know that each major cloud provider today has its strengths and weaknesses. While one cloud provider might provide the best of breed bare metal services, another might excel in big data solutions, while a third one might have a state of the art IoT platform. And strengths are not only technical. While you might be technically very happy with a cloud provider, they might not have a presence in a new market that your business is expanding into. So, in such a scenario, do businesses restrict themselves to some good and other mediocre services? Or do they strive to untie their service availability dependency from a single vendor? Do they live in silos or find alternatives to bring all applications within a distributed yet homogeneous cloud? Do they settle for less or strive for the best of breed in the market? Let's find out. In this next section, we will explore the essence of what it means to adopt a multi cloud strategy. What are a few steps that can be taken to alleviate the business and technical pains faced by organizations today? We also look at a few common use cases for the multi cloud, the problems that they address, and some of the considerations to be wary of when implementing these use cases. With the advent of microservices and distributed architectures, it is now more possible than ever to distribute application workloads across multiple cloud vendors for a single business service. Enterprises can choose different cloud vendors for different applications. The decision can be based on the needs of the service, both from a business and technical perspective, rather than what a specific cloud service provider can offer. The workloads that cannot be moved to a public cloud need not be siloed. A hybrid cloud strategy can be adopted by setting up a private cloud environment for these workloads. This not only allows the consumers to adopt cloud models for these atypical workloads, but also provides a seamless experience by setting up a private, public, or in other words, a hybrid cloud model. Stringent high availability and DR requirements can be addressed across multiple cloud vendors, especially in the case of DR. High speed connectivity, along with vendor neutral platforms, can be utilized to have an effective DR strategy with improved RPO and RTO. Enterprises can segment their applications in layers, which allows them to use more than one cloud vendor across different layers of the application landscape. The prime use case for this is the use of external edge services to improve coverage and application security. We will discuss this shortly. This is by no means a comprehensive list, but a good starting point for anyone looking to adopt a multi cloud strategy. Now, let us move forward and look at some of these use cases in greater detail. Localization is a very common use case and often as a deciding factor for financial and government organizations that deal with sensitive customer data. In today's landscape, it is very likely that these organizations are already using one or more cloud services. We look at a hypothetical company X that is launching a new service in the region represented by the yellow dot. The nature of the service is such that it needs to be hosted within the country. Company X has been using a cloud provider for its other applications. The locations for the existing cloud provider are represented by the purple dots. Customer X is happy with the existing cloud provider, however, it does not have presence in the country where the new app is being launched. Company X now starts exploring other cloud providers. During the exploratory phase, it finds out about another service that fulfills its requirements and also has a presence in the new region. The locations for the new provider are represented by the blue dots. Company X decides to follow a multi-cloud strategy by keeping existing applications as is and moving the new application to the second cloud vendor. Note how the decision making is requirement based and is neither impacted by the lack of presence for the first cloud provider nor the expense of moving existing healthy apps to the new cloud vendor. And if needed, the new and existing services can always be connected using multiple connectivity options such as VPN, in some cases lease-line, and other partner networks. Like any implementations, there are a few considerations to be kept in mind. When using multiple clouds and multiple locations, latency between environments needs to be gauged against requirements of the application itself. Company X would need to consider management of two cloud environments with different management consoles as compared to one environment before. This adds to a learning curve both on the technology and the management front. And last but not the least, interoperability of services between the two clouds. The next use case is deploying a production workload with one cloud vendor and a DR workload with another. This is a very straightforward use case. While one can deploy a DR within a separate zone in the same cloud provider, the multi-cloud approach has its own advantages. For starters, the DR is not bound to the same provider as production. Once replication is set up successfully and tested, the customer is no longer bound to one provider and can move the service and data out much easily in the future if needed. Vendor specific issues can only impact one environment and workloads can be moved seamlessly to ensure service continuity. There are some considerations for this use case as well. These include infrastructure and application architecture that needs to be vendor neutral. Replication requires high speed, low latency connectivity, and as before, the consumer will need to manage multiple clouds. The third use case takes a different approach, and rather than talking about multiple cloud providers, we talk about different types of cloud environments, namely private and public cloud. As discussed before, not all workloads can be moved to a public cloud, and that's where an on premise private cloud comes into play. It allows consumers to adopt cloud technologies while hosting within their own data centers. In a hybrid cloud setup, a private cloud works in tandem with one or more public clouds. This allows the user to use the public cloud as an extension of its private setup. Another use case is to distribute workloads so that core business applications can run in more secure private cloud, while non-critical workloads can be offloaded to a cheaper public cloud. Consumers could choose where to host their workloads based on the need and budget, resulting in better service and improved cost optimization. The two environments can always be connected via multiple options such as VPN, lease line, or direct access via the internet. In an ideal scenario, The customer should be able to manage both environments from a single console and seamlessly move workloads between the two. The considerations for this use case include apps that must support cloud bursting, services must be interoperable, and ideally, the customer should get a single management pane. The fourth use case is related to edge services. This is probably one of the most highly adopted multi-cloud use cases. On the right side of the screen, you see a sample application with the different layers stated separately. You could, under normal circumstances, deploy this within a single cloud provider. However, let's say you liked an external DNS service better, or you have an existing DNS provider. You can easily use an external DNS with the rest of the layers deployed with your existing cloud provider. Similarly, you could also decouple CDN services. It is not necessary that you use the CDN from within your cloud provider. If you find a CDN provider with better coverage in your target geography, in most cases, you can use that with your existing application. Now let's assume your cloud provider WAF is not that great or is not located close to your application. In that case, you can club an external WAF with your application if your cloud provider and the external WAF provider allows. You can get more adventurous and throw in a mix of more than two providers. However, like with other use cases, you need to be wary of the considerations. Inter-provider latency and support could become an issue. When you are dealing with multiple cloud providers, especially on edge services, the services changes are not automatically populated across the layers. So you might need to do manual changes across the two clouds. And if you use a lot of cloud providers, there might be too much segmentation of traffic across these clouds. So all these considerations need to be kept in mind when splitting away your edge services. The final use case that we will discuss is about distributing your service workload across multiple cloud providers. What this means is launching a single application across a multitude of public clouds. The specific architectural details on how these services can be designed is beyond the scope of today's discussion. However, we will discuss certain core elements that support such deployments. To begin with, microservices are at the heart of distributed architecture, and the leading technologies for containers and orchestration services include Docker and Kubernetes. So those are some of the technologies you should be looking for when trying to support a multi-cloud strategy. Distributed applications require a high amount of cross-cloud automation, and tools such as Ansible, Puppet, Chef, etc. can be used to create an abstraction layer to achieve automatic cross-cloud orchestration and scaling. If the infrastructure needs to be manipulated via automation tools, then the cloud management functions must be exposed via standard open APIs. Other infrastructure components include cross-cloud replication support, software-defined networking capabilities, and globally accessible low-latency storage, to name a few. On the application layer, of course, on the web app layer, you would be looking at something that is cloud native, which means it's stateless and horizontally scalable. Similarly, on the database layer, you would be looking at something that is elastic, scalable, and is supported across multiple vendors. Distributed workloads can be deployed using multiple architectures. You could distribute one or more service layers with data storage replication if needed. You could create disparate clusters across different clouds with scheduled or continuous data synchronization. You could also have a single point of entry to the application and build a virtual private cloud across multiple cloud providers. In the third section of the webinar, we talk about how at Alibaba Cloud, we are constantly innovating to support a multi-cloud strategy for our customers. When it comes to supporting a multi-cloud strategy, there are some core technology pillars that need to be supported by the cloud vendors. To begin with, the cloud provider must allow multiple channels for connectivity into the tenant environments from external IDCs and other cloud providers. There must be a heavy focus on open source and vendor neutral technologies to allow easy interoperability across different cloud environments. There must be support for a rich set of integration tools for migration, data ingestion, and data export across different environments. There must be support for synchronization of data, standard automation tools to support cross-platform data consistency, and automated orchestration and scaling across clouds. We will now go ahead and discuss how Alibaba Cloud ticks all these boxes in its support for a multi-cloud strategy. If you look at connectivity options, Alibaba Cloud provides a multitude of options to connect into environments within Alibaba Cloud. The first one that we are going to look at is Virtual Private Network or VPN Gateway. Alibaba Cloud provides standard site-to-site IPsec VPN. This IPsec VPN can be used to connect to an external data center or any other cloud provider that supports standard IPsec VPNs. Alibaba Cloud also provides point-to-site SSL VPNs if needed. The second option available to customers is Express Connect. Express Connect is a service by Alibaba Cloud that allows connecting into your virtual private cloud tenant within Alibaba network from an external IDC. Now, this external IDC could be another cloud provider or could be an on-premise deployment for the customer. Several options are available. Some of them include high-speed lease line connections and also connections via access partner networks. Another connectivity option available within Alibaba Cloud is Cloud Enterprise Network. If you are running a global service within different regions of Alibaba Cloud, all these regions can be connected onto a very high-speed cloud enterprise network. And then from different sites, individual on-premise IDCs could be connected using lease line connections. So as you can see, a number of connectivity options are available when it comes to Alibaba Cloud deployments. If we look at infrastructure components and emphasis on cross-cloud compatibility, look at operating systems. Most of the popular x86 enterprise operating systems are available for use in Alibaba Cloud. These are standard operating systems that can be ported to and from other clouds. Alibaba Cloud supports a number of industry standard databases on both infrastructure as a service option as well as managed service option. Some of them include MySQL, Postgres, PPaaS, and memory databases such as Redis and Memcache, and NoSQL such as MongoDB. From a microservices perspective, Alibaba Cloud supports both Docker Swarm deployments and Kubernetes deployments. Both these deployments use the Docker containerization at the backend. We also provide container registry services. If you look at big data deployments, Alibaba Cloud provides a service that gives you a fully managed Hadoop cluster within Alibaba Cloud. This Hadoop cluster supports standard integrations from Apache Spark, MapReduce, Pig, Scoop, Spark SQL, HDFS, and HBase. Alibaba Cloud provides a number of edge services that could be seamlessly integrated into a multi-cloud application. So let's say you were using another third-party cloud provider, you could use these edge services to complement your existing application architecture within another cloud. Last but not the least, Alibaba Cloud provides its customers a private cloud solution. This solution is known as Apsara Stack. The solution allows you to build your own on-premise hyperscale cloud with unrivaled computing power. It is a multi-cloud scenario. This means you can set up a hybrid cloud with a combination of private and public cloud sites, orchestrated and monitored from a single management pane. What are the different tools for multi-cloud that are available within Alibaba Cloud? Alibaba Cloud provides fully documented open RESTful APIs to access all of its cloud functions. There are a multitude of options available for data integration and synchronization. Data integration supports data synchronization between more than 400 pairs of disparate data sources, including RDS databases, semi-structured storage, non-structured storage, NoSQL, and so on. It also supports real-time data reading and writing between data sources such as Oracle, MySQL, and DataHub. This allows integrating data across different channels, across different clouds. Alibaba Cloud Terraform Provider enables you to safely and predictably create, change, and improve Alibaba Cloud infrastructure. Now, Terraform, if you don't know, is an orchestration tool which uses an Ansible-like format to deploy cloud infrastructure dynamically. It creates an abstraction layer and provides you with the means to dynamically deploy and control your cloud infrastructure. There is another service called Data Transmission Service that allows you to easily import data from other environments into Alibaba Cloud RDS databases. This concludes the presentation part of the session.